Welcome back to PreCalculus. Hope you guys had a good time with the Chapter 8 test. Today we're going to get ourselves started on Chapter 9. And what we focus on here in the first four sections of Chapter 9 are what are called the conic sections. And what we do with the conic sections is we take what's called a double napped cone. In fact, let me write that out for you. We take a double napped cone, which you see off to the right. And we take this double napped cone, which just means we have a cone above, we have a cone below, and we put the two apexes or the two tips together. So we have a cone opening up and we have a cone opening down. That's called a double napped cone. And then what we do to produce the conic sections is we pass a plane, a flat surface that goes on forever. We pass a plane through the double napped cone at different angles. And when we pass it through at different angles, we get four different shapes. As an example, I'm going to jump to the second one here. If we take a plane and pass it through the cones parallel to one of the bases, we create what is known as a circle. If we take that plane and tip it just a little bit, it essentially stretches that circle out, and we form what's called an ellipse. If we take that plane and tip it at a greater angle, so that it then becomes parallel to one of the sides of the cone, then we create a shape known as a parabola. And if we continue to tip that plane until it hits both the top and the bottom of both parts of the cone, so it intersects the upper cone and it intersects the bottom cone, then we create a curve made up of two parts that's called a hyperbola. Now, all of these curves we talked about back in Algebra 2. We went through all of these, but we went through them just as an introduction. We just kind of gave you a brief, just a little bit of the basic information about each of these shapes. These shapes have been studied for about 2,200 years. They've been studied since about, somewhere in the 200 BC range is when they were first studied by the Greeks. And they continue to offer a lot of applications to us today. These four basic shapes, the parabola, the circle, the ellipse, and the hyperbola, continue to be very useful mathematical tools for us. And therefore, we're going to spend a lot of our time and a lot of our energy focusing on these four shapes. Now, for most of you guys who go to college, this is going to be the last time that you'll ever really intensely study these four shapes. From now on, when you go to university, college somewhere, you're going to be expected to know how to work with these shapes. This will be the last time you really have to work through all of them. Okay? So what we're going to do, though, is we're not just going to look at the shapes. We're going to look at the equations that govern each of the shapes. And for each of the four basic shapes, the parabola, the circle, the ellipse, and the hyperbola, we're going to look at what's called the general form for all conic sections. All right? And it's this equation that looks terribly complicated at first. ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. All right, we're going to look at that equation. And as we go through each of the shapes, I'm going to give you guys conditions for A, B, and C that will dictate which of the four shapes this equation becomes. We're going to essentially start with this equation for all four of those shapes. We're going to start with this equation for parabolas, for circles, for ellipses, and for hyperbolas. And then I'm going to give you conditions for A, B, and C that will dictate what type of shape we have. Okay? Now, please please notice, I guess I should say, that if certain values here weren't there, so as an example, if the A was 0, the B was 0, and the C was 0, if A, B, and C were all equal to 0, then all we'd be left with is an equation with x and y raised to the first power. D, E, and F are just going to be some constants. So we'd have an equation in terms of x to the first and y to the first, and what would that be? If we eliminated the a, b, and c, then all we're talking about is a line. Okay, so actually, the general form for a conic section can get us all the way down to just a line as well. But for the most part, we're not going to worry about the lines. We've done that to death. What we're going to focus on is what happens with that equation to form a parabola, to form a circle, to form an ellipse, to form a hyperbola. Okay, so we're going to be giving you guys different conditions for A, B, and C that will dictate what type of shape we have. Okay? Alrighty. So let's go ahead and get ourselves started with shape number 1, and we're going to choose to work ourselves through the circle first. Now, for each of the 4 basic shapes, I'm going to give you a definition, right? And all of the definitions are going to start off with the same phrase. They're going to start off with this phrase, the collection of all points. And then there's going to be some conditions about these points that dictates whether it's a circle or a parabola or an ellipse or a hyperbola. Okay, so we're going to start off every one of these with a definition. Okay, for a circle, the definition is collection of all points equidistant from one fixed point. And I've left a couple of parentheses there because I want to define the equal distance and I want to define the fixed point. Okay? Now the fixed point we call the center of the circle, and I'm going to use a C to denote that on my first picture here. All right? The center is the fixed point. And then whatever the equal distance is, we put that together as one word, equidistant, we call that value the radius. So the distance from the center to this point, or the distance from the center to this point, all of those distances must be equal. So all of those radii must be the same. So the circle is made up of all of these points, the collection of all of these points that are equidistant from that center point. So I draw the line from the center to any one of the points I've just indicated on the circle, like that one right there. And as long as that distance is the same as all of the other ones, every one of those points then, when we put all of those infinite number of points together, we form a circle. Okay? Next, what about the general form? And what I mean by general form, let me just back up quickly. Going back to our original equation that's going to represent all of the conic sections, what about the general form makes an equation be a circle? All right, and there's going to be two things. Okay, so you can see them right here. There's going to be two things. First of all, the b value has to be 0. So there's going to be no xy term. And secondly, the value for a and the value for c have to be equal to each other. So again, if I back up, if b is equal to 0, so we're not going to have an xy term. And then if the a and the c are equal to each other, whatever number's in front of the x squared is equal to whatever number's in front of the y squared. If those two are equal to each other, then we have a circle. So those are the two conditions that have to be true about the general form for the equation to represent a circle. And of course, for all of the other shapes, for parabolas, ellipses, hyperbolas, we'll have different sets of conditions. Okay? And then for each of our forms, we're also going to give you what's called standard form. And this is going to be kind of our working form that allows us to get information about a circle or a parabola or whatever shape we might be talking about. So as you guys are going to be creating notes in your notebook here, I'm going to need to make sure you write down what conditions make something a circle in the first place, so letter A, and also the standard form for whatever shape we're talking about. So here we're talking about a circle. So the standard form for the equation of a circle is this: x minus h, please notice quantity squared, don't forget the squared, plus y minus k, quantity squared, is equal to r squared. Notice there's a power of 2 on each of the terms. And then the center of the circle, remember that's the fixed point, the center is defined by h comma k, And please notice in the equation we have x minus h, but then the center is located at h. Y minus k, but then the center is located at k. In other words, the coordinates of the center are always the opposite of whatever sign is inside the parentheses. And I sure hope that sounds familiar. Anything inside parentheses is always opposite of the sign. And then finally, the radius, the equidistance from our definition, is always going to be equal to, now I know this looks ridiculous, it's like, why would you bother writing that down? But it's a good thing to jot down because in the equation, the number on the right-hand side is not r, it's r squared. So anytime we want to calculate the radius, we have to take the square root of whatever number's on the right-hand side. So the square root of r squared, of course, is just plain old r. No surprise there. Okay, so the first thing I want to do in this video is go through some examples of equations written in standard form, and I'm going to ask you guys to find certain pieces of information. Now there's going to be, overall, there's going to be two types of problems that we do. Today, what we're going to do on this first video is start with the equation of a circle and go to the graph, tell me where the center is, and tell me what the radius is. But on the next video for circles, I'm going to do this in reverse, give you information about the graph, the center, or the radius, and ask you to work backwards to the equation. So the idea is we want to be able to do all of these problems, not just circles, but we'll do the same thing with parabolas. We'll do the same thing with ellipses. We'll do the same thing with hyperbolas. We want to be able to work these problems in both directions, right? Just like everything in math, we try to learn everything in both directions. You learn something in both directions, you're going to understand it better and better and better. Okay, so let's go ahead and get ourselves started. Again, I'm going to begin by giving you guys equations in standard form and then asking you, let me choose my laser pointer here so I can highlight it, asking you guys for three things. I'm going to expect you guys to be able to tell me what the center of the circle is, the radius of the circle, and then I want you to draw me a decent graph. Okay? So from the standard form, can you guys get me those three pieces of information? The answer is yes. The center is going to be located at h comma k. But again, whenever we have parentheses in an equation, we always have to take the opposite of the signs. So what's the x coordinate for the center? The opposite of -4 is +4. And what's the y coordinate? The opposite of +2 is -2. So on our picture, what I expect out of you guys is to go 4 to the right, 1, 2, 3, 4, and go down 2. And whenever possible, you can give me a little C there. That represents the center. Then the radius of the circle is going to be the square root of whatever number is on the right-hand side. Remember, this isn't r. The number on the right-hand side is always r squared. So we have to take the square root of that. Of course, I rigged a few of these to make sure they turn out nice and easy peasy. The square root of 9 is 3. And then what I expect out of you guys, from the center, I want you to show me that you understand the radius by going up 3, 1, 2, 3, right 3, 1, 2, 3, down 3, 1, 2, 1, 2, 3, there it is, and left 3, 1, 2, 3. So what I'm going to ask you to do is go up 3, down 3, right 3, left 3, and then through those four points, I'm just going to ask you to do the best you can. Don't need a compass or anything like that. Just do the best you can to sketch in a circle. All right? And if nothing else, you can always get some graph paper off the internet. Just do a Google search for graph paper if you want some for yourself to draw some decent pictures. Okay? All right, let's try a few more. Again, with the equation in standard form, what I'm going to ask you for is the center, the radius, and I'm going to ask you to draw me a decent picture. So on this one, remembering anything inside parentheses is opposite of the sign. So the x-coordinate, the opposite of +1 is -1, and for the y-coordinate, the opposite of -5 is +5. Let me get a better 5 down there, guys. There we go, that looks a little better. And then the radius is going to be the square root of the number on the right-hand side. So the square root of whatever number is on the right-hand side. So the square root of 25 gives us 5. And then third, draw a picture. So again, center, radius, graph. So the picture this time, the center is left 1, up 5. So I've traveled 1 to the left and gone up 5. And then because the radius is 5, I want you to go up 5, down 5, right 5, 1, 2, 3, 4, 5, and left 5, 1, 2, 3, 4, 5. I think I got that okay. And then through those 4 points, just do the best you can to draw yourself a decent circle. Hey, that one's not too bad for old people. That one wasn't too bad. Okay, so everyone doing all right? Now I'm going to ask you to do one more of those. And when you first look at this one, you might think, well, gee whiz, that's simple. That's a lot easier than the previous ones, but I just want to make sure we're all okay on this. All right? This time there's no parentheses. We don't have x minus h, y minus k. We don't have any parentheses with the x's and the y's. Now, if there's no x to the first or y to the first, that just simply means that the center of the circle is located at 0, 0. All right, that's all that means. And then the radius is just going to be the square root of 16 in this case. So the square root of 16 is 4. And what that would tell me to do is go up 4, down 4, right 4, left 4. And again, do your best. All right, that one's a little shakier. But do your best to put a circle through those 4 points. Okay, now we're going to change things up a little bit and make things a little bit harder. All right, now you can see that we have an equation not in standard form but in general form. All right, how do I know it's in general form? Because I have 1x squared, 1y squared, then negative 2x, negative 4y, minus 20. Now I have an A, a C, D, E, and F term. I've got extra numbers here. And the problem is, when it's in general form, please notice no parentheses, but I've got an x to the first and a y to the first. Now it's not in standard form. How am I supposed to know where the center is? And how am I supposed to know where what the radius is? How am I supposed to be able to do that? Okay, so now the objective, and this is going to be tougher, now the objective is going to be, I need to work from general form into standard form. And that's going to require a skill that you've seen before, but now it's no longer an option. Now it's going to be required. A skill called completing the square. You've seen it before. I've shown it to you before, actually twice before, once this year and once back in Algebra 2. But now we need to be able to complete the square. And don't think this is going to be a one-time thing. We're going to need to do this for all of our shapes. So we're going to be completing the square for circles, for parabolas, for ellipses, and for hyperbolas. Okay? So here's the process, I should say, as to how you complete the square. Ready to go? All right, so what you need to start with is putting the x's together. So put the x squared and the minus 2x together. Leave a space after the 2x, just trust me. Then put the y's together, so put the y squared and the negative 4y together, and again leave a space after that. Then move the constant, the number that doesn't have a variable, to the other side, in this case by addition. Okay? So let me just repeat, put the x's together, put the y's together, and move the number without a variable to the other side. Now the only rule on completing the square is you have to have a 1 in front of the squared term. You have to have a 1. What number's in front of our x squared? A 1. What number's in front of our y squared? A 1. So we're in good shape. Later on we'll have to worry about that. What happens if we don't have a 1 in front of the x squared and the y squared? Okay? So here we go. What we need to do is complete the square for the x's, and to do that we need to add a blank on both sides. Now, would everyone agree that if I add the same number in the blank on both sides, that's legal? So I could add a 17 in the blank on both sides, that would be legal. I could add a 34 in the blank on both sides. In fact, let me do that. So add a 34 here and there. That would be legal because I'm adding the same number on both sides of the equation. I actually don't want the 34, but I could, as long as I had the same number on both sides, that would be legal. Now, I'm going to need to do that for both the x's and the y's. So I add a second blank, one next to the y's, and then a second blank on the right. Now I'm going to perform a step called completing the square. And what we do with completing the square is we form a binomial, so it's got two terms, and then we have a power of 2. So we do what's called completing the square. We form a binomial, two terms, squared. Now the first term is going to be the variable right up above. What variable is directly above the parentheses there? An x. And then the second term we get by taking the number sitting in front of the x and dividing by 2. Always, no matter what the number is, positive, negative, big, small, decimals, whatever it is, we divide by 2. So in this case, -2 divided by 2 is -1. Now whatever number goes in the parentheses, here it's a -1, we've got to square that number. Again, whatever number goes in the parentheses, we have to square that number. So -1 times -1 is 1. And that becomes the first number in the blanks on both sides. Okay? Now we do the same thing for the y's. We complete the square for the y's, which means we form a binomial squared for the y's. The first term in the binomial is the variable above, so now that's a y. And the second term we get by taking the number in front of the y and dividing by 2. Always divide by 2. So -4 divided by 2 is -2. Then whatever number goes in the parentheses, whatever number went into the parentheses, we have to square that number. So -2 times -2 is 4, and that's the second number we add in the blanks on both sides. Now to finish off this step, we just simply have to, let me change colors here, let me select blue for a second. We have to finish off this step by adding those three numbers together. 20, 1, and 4 is 25. And now we have the equation in standard form. So now everybody should be able to tell me the location of the center, remembering opposite signs. For the x, the opposite of -1 is +1. And for the y, the opposite of -2 is +2. And then the radius is going to be the square root of the number that's on the right-hand side. So the square root of 25 is 5. So the center of our circle is located at 1, 2. So there's the center. And then the radius is 5, so I want you to go up 5. 1, 2, 3, 4, 5. Down 5. 1, 2, 3, 4, 5. Right 5. And finally left 5. 1, 2, 3. And then through those 4 points, do the best you can to draw a decent circle. All right? And again, what I'm going to expect out of you guys is the center, the radius, and a decent picture. Okay, before we leave this, what the heck is with this adding in the blank on both sides? So now let me switch to blue. Usually, if this was just any regular problem, we'd be done. But what's the scoop with the needing to add the 1? Okay? So why did we go through this whole spiel? Because once the 1 is there, once the +1 is there, now I think everyone would agree that in blue what you're looking at is a trinomial, and trinomials can always be factored into two binomials. And can anyone think of what lasts would multiply together to get +1, but add to get -2? And what works out is -1 and -1. But hey, those two binomials are exactly the same, so I can actually write that as one of them squared. So of course that's where that fella comes from. And the process I just showed you of dividing by 2, then whatever number goes in the parentheses, squaring, will always create a trinomial that can be factored. As an example, this fella right here, y squared minus 4y plus 4. That can be factored into y minus 2 and y minus 2, which can then be written as y minus 2 squared, which of course is right there. Okay, now I know I've made a mess of this one. Normally we won't do all of the stuff in blue, but I just wanted to show you on the first one how that works. Okay, so let's try a couple more of the completing the square problems. All right, here's another one as an example, where the equation's written in general form because we have an x squared, y squared, x to the first, y to the first, and number term. All right, so to go from general form to standard form, we have to do what's called completing the square. And to accomplish that, we have to put the x's together. So I put the x squared and the 6x together. I have to put the y's together, so y squared and the minus 10y together. And then I have to move this negative 2 to the other side, so I add it. Now, the only rule for completing the square is we have to have a 1 in front of the squared term. Right now we have a 1 in front of the x squared and we have a 1 in front of the y squared, so we're in good shape. All right, so first thing we do is add a blank on both sides so we can complete the square for the x's. We add a blank on both sides so we can complete the square for the y's. Then we actually go ahead and complete the square. Remember, that's a binomial squared. The first term is the variable above. The second term we get by taking the number in front of the x and dividing by 2. 6 divided by 2 is 3. Then whatever number goes in the parentheses, 3, we have to square it, so 3 times 3 is 9, and that becomes the first number in the blank on both sides. Okay? Then we do the same thing for the y's. We complete the square for the y's, so we form a binomial squared. The first term is the variable above. The second term we get by taking the number in front of the y and dividing by 2. Negative 10 divided by 2 is negative 5. Whatever number goes in the parentheses, square it. So negative 5 times negative 5 is 25. Back up and add in the second blank on both sides. Okay? And then to finish this step off, we just add these three numbers together. 2 plus 9 plus 25 is 36. And now we've gone from general form to standard form. So everybody should be able to tell me the location of the center and the value for the radius. The center, remembering opposite signs when we have numbers inside parentheses. For the x, the opposite of positive 3 is negative 3, and for the y, the opposite of negative 5 is positive 5. And then the radius is going to be the square root of the number on the right-hand side. So here, that's the square root of 36, which is 6. So the center is going to be 3 to the left and up 5. So 1, 2, 3, 4, 5. So the center is going to be right about there. And then what I'm going to need to do is go up 6, down 6, right 6, left 6. So I'm just going to do the best I can here. Up. Let's see. 1, 2, 3. There's right. There's down. And there's 1, 2, 3, 4, 5, 6. Okay, so we went up 6, down 6, right 6, left 6. And I'm just going to do the best I can. To sketch in, a little shaky on the top side there, but sketch in a decent picture for a circle. Okay? Alrighty. The next example, and again, like always, feel free to pause these if you need to take a closer look at anything. The next one requires one little extra step. All right, and again, the idea is we know this is a circle because the value for A and the value for C are equal to each other. Each A and C here are 2, so we know this is going to be a circle. Now, the idea would be, again, to put the x's together, so 2x squared and the minus 4x, the y's together, the 2y squared and the 12y, and then move this number to the other side. But before we can complete the square, we have to have a 1 in front of the squared terms. We have 2's. We don't want the 2's. So what we're going to do is divide the whole equation through by 2. And as long as you divide both sides of the equation by the same thing, legal. Okay? So we're going to divide 2 by 2 to get 1x squared, negative 4 by 2 to get negative 2x, 2 by 2 to get 1y squared, 12 divided by 2 is 6y, and negative 18 divided by 2 is negative 9. Now we're right back to where we were on the previous examples, where we can add a blank on both sides so we can complete the square for the x's, add another blank on both sides so we can complete the square for the y's. And then go ahead and complete the square for the x's, the variable above, then take the number in front of the x and divide by 2. Whatever number goes in the parentheses, square it. -1 times -1 is +1. And then complete the square for the y's, taking the number sitting in front of the x, in front of the y, sorry about that, and dividing by 2. So 6 divided by 2 is 3. Whatever number goes in the parentheses, square it. So 3 times 3 is 9. Back up and add a 9 in, the second blank on both sides. And then to finish up, we just need to add those three numbers together. So -1 plus 1 plus 9 is +1. And again, everybody should be able to tell me the location of the center and the radius. Remembering opposite signs, the opposite of -1 is +1, and the opposite of +1 is, oops, sorry, I said that wrong. The opposite of +3 is -3. And then the radius is going to be the square root of the number on the right-hand side, so the square root of 1 is 1. This is going to be a little tougher to draw because it's really small, but let me do it here. The center, write 1, down 3. This time I'm not going to write a C on the center because the radius is only 1, so it's going to be really tight here. So I'll just do the best I can. Go up 1, down 1, left 1, right 1. So I'm just doing the best I can there for a picture of the center. Okay? And then finally, one last comment before we call it a video. Okay? And I just need to make one comment. When we start with an equation, whether it's in general form or in standard form, usually we'll start in general form. We do the completing the square part, and whenever this number, let me highlight this in red, whenever the number on the right-hand side is positive, we're good to go. We can take the square root of whatever that number is to find the radius. But unfortunately, there's two other options for this number that's on the right-hand side. That number can sometimes turn out to be 0, or that number on the right-hand side can turn out to be less than 0. Now again, greater than 0, we're good. We just take the square root, we have the radius, we're all set to go. But if it's equal to 0, we have a special situation. And you might think, well, how can I draw a circle with a radius of 0? Because you'd think, well, if that's actually equal to 0, r squared is equal to 0, so when I take the square root of both sides, r is equal to 0. So how in the world am I supposed to do that? Well, what we end up with is a special situation that's called a point circle, where there's only one point that makes the equation true, and that's the location of the center. Okay? So the center point is the only point on the circle. There's just that one single point. And if we ever end up with a situation where the number on the right-hand side is negative, less than 0, then there's no possible circle that we can draw here. There's no possible circle that we can draw because we'd be taking, remembering r squared is equal to that number. So if this is a negative something, when we take the square root, we'd end up with an I attached. And we can't do that. So we'd say there's no possible circle. There's also a fancy word the textbook uses. I don't care if you guys remember. This is also called a degenerate. See if I remember how to spell it. Degenerate. Yep, there it is. It's also called a degenerate circle. But I would just ask you guys to remember to say there's no circle possible. Okay? So I know this was a real long video. Sorry about that, guys. But this is we're done with the first half of circles. There's going to be another video that will talk about circles before moving on to parabolas. So take a little bit of break, have a little bit of a walk around, have a little Diet Mountain Dew, and then come back for the next video. All right, hope you're having a good day. See you soon.